Welcome to the Lion's Share podcast, where we break down today's most impactful research and bring fresh insights from the academic frontier straight to you.
Okay, let's unpack this. For practitioners and strategists, I think autonomy is often felt like something, well, over the horizon, futuristic. But if you actually look at the source material we've pulled together today, it feels like we are right at that inflection point. I mean, the snapshot that really captures this acceleration, Amazon, the U.S.'s second biggest private employer, they're apparently on the cusp of having as many robots as human workers.
It's over 1 million robots already in their global facilities. It's staggering.
Exactly. So autonomy, it's not some distant trend anymore. It's actively reshaping labor markets, corporate strategy right now. Our mission really for this deep dive is to take all this data covering everything from warehouse bots to driverless trucks, drones, and distill what it really means. The implications for corporate innovation, for market structure, and maybe even future managerial relevance. We're aiming this squarely at the highest level of strategic thinking.
And what's fascinating, I think, is that we're moving beyond just how does the tech work. We're diving straight into, okay, what does this mean for your business model? We really have to look at this acceleration through the lens of market structure, competitive strategy, this huge technological shift. Well, it dictates where investment priorities have to lie, doesn't it?
Right. So let's maybe set the scene a bit. Define the scale of this transformation. We're talking about the whole supply chain here. It's an evolution, isn't it? From, simple numerical control tools way back in the 40s to today's really complex AI-guided autonomous systems.
And crucially, the key concept separating this generation of tech from just simple automation is autonomy as a continuum. We aren't talking about simple on-off systems. We mean the machine's ability to make complex decisions in real time, adapt to dynamic, unpredictable environments, all without constant human input.
That decision-making power.
That's the engine. That's the revolution right there.
And the economic engine is just colossal. If you look just at the global autonomous vehicle market, not even counting warehouse robotics or drones, it was valued at, $1.5 trillion in 2022?
Mm-hmm.
The projection for 2030 is mind-boggling.
Mm-hmm.
Over $13.6 trillion. That's a compound annual growth rate of 32.3%.
That's not growth. It's an explosion, really.
Exactly. That kind of magnitude demands a strategy response. You can't ignore it.
You can't. And when you see an economic tidal wave like that coming, companies, well, they have little choice but to start deploying systems, maybe even before they're perfect. Let's look at the leading edge, Amazon.
Perfect example. Amazon really serves as the bellwether for automating logistics, doesn't it?
Mm-hmm.
They've deployed over 1 million machines using things like wheeled droids, ferrying goods, and even this Vulcan robot that apparently has a sense of touch for handling items.
And the output figures, I think this is what should really grab managers' attention. The number of packages Amazon ships annually per employee, it's just climbed steadily since 2015. It went from about 175 packages per employee back then to, roughly 3,870 packages per employee today.
Wow.
That extreme efficiency lets them dramatically slow hiring. It actually means the average number of employees per facility is the lowest it's been in something like 16 years.
Okay, but here's the tension point, right?
So,
Amazon is actively promoting the fact they've trained over 700,000 workers globally, training them for higher paying roles, robot technicians, mechatronics, system supervisors. There's that story of Nisha Cruz, who went from picking items to overseeing mobile robots, earning 2.5 times more.
Mm-hmm.
And this isn't just standard job training. You could argue it's a massive entrepreneurial strategy. They're building technical talent from their existing workforce.
Instead of fighting it out in the, hyper-competitive external market for software talent. And that's the critical contrast strategists need to get their heads around. Amazon's selling the upskilling narrative, and look, it's true for people like Nisha Cruz. But the internal calculus, some sources suggest, points to a deeper, long-term goal. Warehouse employee advocates point out the company's stated dream to have significant reduction of workforce in high-density facilities.
So a net win for productivity.
Definitely. But it signals a potential net loss for traditional lower-skilled jobs down the line. That's the other side of the coin.
Okay, so we've seen the constraints, the dynamics inside the warehouse. But what happens when you take these systems outside, where the challenges are completely different? Let's talk driverless trucking. The shift towards commercial autonomous vehicles, AVs, seems intensely pragmatic. It's fueled by that massive shortage, over 80,000 truck drivers needed in the U.S.
Yeah, and the complexity just jumps immediately, doesn't it? You go from a controlled warehouse environment to the sheer chaos of public roads. Companies like Waymo, They've logged, over 20 million physical miles and billions, literally billions of simulation moments.
20 billion, yeah.
And they're crystal clear. The biggest hurdle for their level 4 and level 5 systems. Dealing with the anomalies, the unexpected things caused by unpredictable human drivers.
So it's us. We're the problem.
Ironically, yes. Bad human driving is probably the single deepest challenge in the entire self-driving space right now.
That brings us neatly to a key concept we should clarify. The levels of autonomy.
Yeah.
L1 through L5, L1, L2, and L3, things like automated braking, adaptive cruise control. They're really focused on augmenting the human driver, right? They hold the biggest market share currently.
Exactly. They enhance driving. But L4 and L5, they're the truly driverless systems. L3 is actually paradoxically seen as maybe the hardest level.
Why is that?
Because it requires the machine to reliably hand control back to a potentially unprepared human driver under stress. That handover is technically and legally fraught. L4 operates autonomously under specific conditions, like a geofenced area or good weather. L5 is the sort of holy grail, full autonomy under all conditions. And that leap from needing human input to needing no human input, that's precisely the jump regulators are wary of. It's why the regulatory friction is so incredibly high.
Yeah, that lack of clear, consistent regulatory frameworks seems to be the major break on L4, L5 adoption, wouldn't you say?
Absolutely.
We saw that example where the California governor recently vetoed a bill that would have mandated human safety drivers in heavy self-driving trucks.
Right. The tech might be getting there or close, but the political and social uncertainty, that's actively slowing things down.
Okay, let's pivot again to the smallest autonomous vehicle, drones. Specifically for last mile delivery, drone activity is definitely growing. We saw figures of over 2,000 commercial deliveries daily back in early 2022. But when you look at the cost.
Yeah, the economics are tough right now. A single package drone delivery currently costs around $13.50. That's just not competitive with traditional methods yet.
And why is it so high?
Well, if we connect this to the bigger picture, the reason for that crippling cost isn't the drone hardware itself. It's overwhelmingly the regulatory environment. Labor. Labor represents up to 95% of that $13.50 cost.
95%? Wow.
Yeah, because current FAA rules often demand a human visual observer on the ground or strictly limit operations to one operator per drone. That 1-to-1 ratio just kills the economic model.
So the innovation target's pretty stark then. Get that cost down to maybe $1.50 to $2 per delivery to be competitive.
Exactly. And achieving that requires a massive regulatory shift, allowing a single certified operator to safely manage a whole fleet, maybe up to 20 drones simultaneously. That's the technological and regulatory goalpost.
Makes sense.
But while logistics wrestles with that regulatory bottleneck, we shouldn't ignore the value drones are already delivering elsewhere. Think agriculture. Using infrared cameras to spot crop stress, doing highly precise spraying, they're massively boosting efficiency and precision. The resource savings are already transformative.
What kind of savings are we talking?
Globally, the data suggests cumulative savings of something like 210 million metric tons of water. And reducing chemical use by about 47,000 metric tons, that's significant environmental impact right there.
Huge numbers. Okay, so let's shift gears slightly and move into the strategic critique. We've got these case studies now. We saw Amazon using its scale, its vertical integration to automate at just breakneck speed. First question then, does this Amazon case, where automation is accelerating so fast it's fundamentally changing the workforce, does it validate or maybe challenge traditional theories of technology adoption?
That's a great question. What's fascinating here is that I think it challenges the sort of assumed smooth, linear S-curve of adoption we often talk about. Traditional models often assume gradual diffusion through a market. But Amazon, by building its own robotics divisions and leveraging its massive operational scale, well, they're demonstrating a highly accelerated, almost scale-dependent model of disruptive adoption.
Scale-dependent.
Yeah, they effectively compress the S-curve. They do it by focusing investment on proprietary tech and then immediately deploying it to critical mass within their own controlled environment.
So the lesson for other firms might be?
That vertical integration in robotics, if you have the scale, allows for potentially non-linear leaps in adoption and productivity. It's not a path available to everyone, though.
Interesting. Okay, let's talk about market strategy and trust. We heard consumers are interested in AV features, but trust in fully autonomous vehicles actually dipped recently.
Yeah.
Declined by 5 percentage points. So how should car manufacturers, the OEMs, structure their go-to-market strategy? How do they monetize these advanced systems when the public is clearly still skeptical about L4, L5?
Yeah, this raises a really important point about the underlying business model. OEMs need to recognize they're fundamentally shifting. They're moving away from just selling a piece of hardware, a car, towards managing the entire life cycle revenue stream. We sometimes call this the end-to-end or E2E business model.
End-to-end.
And since the data suggests consumers prefer flexible pricing, like, say, pay-per-use for a highway autopilot feature or a monthly subscription for advanced parking assist.
Right? Like software.
Exactly like software. So OEMs probably need to equip the necessary hardware up front, maybe even as standard, and then really focus on securing that long-term software-driven recurring revenue. That's a big mental shift from traditional car sales.
A huge shift.
Yeah.
Okay, thinking about the drone dilemma again, that 95% labor cost due to regulation. What proactive innovation strategies can firms actually employ now, today? How do they prepare for that eventual L4, L5 tech and regulatory shift that might unlock the $1.50 delivery cost? What can they do while they wait?
Well, they need to focus on what they can control, which is largely infrastructure modification. Our sources suggest firms should be looking at modifying existing distribution centers, maybe even retail stores, to be drone-ready right now.
Yeah.
Setting up standardized landing pads, charging stations, integration points.
Preparing the physical world.
Precisely. And also forging strategic partnerships. Working with the drone tech providers now to co-develop the necessary unmanned traffic management systems, the UTMs. Being ready for the regulatory shift means having the groundwork laid.
Yeah, got it. Let's revisit talent for a moment.
Yeah.
We talked about Amazon training 700,000 internal workers, leveraging that entrepreneurial strategy successfully. How does that compare to the situation in autonomous vehicles, where success seems to hinge almost entirely on attracting scarce, specialized external coding talent?
The comparison really highlights two very different talent battles, doesn't it? Amazon is focusing on leveraging its huge internal workforce, training them up, capitalizing on their existing knowledge of logistics and scale. The AV space, though, it feels much more like a classic tech winner-takes-most scenario. It's focused almost purely on achieving technological superiority through software. Success there hinges on attracting and retaining the absolute top-tier external software development talent globally. Leading AV players often have relatively smaller but incredibly specialized software teams.
So in AVs, it's talent concentration, not just resource deployment.
Exactly. Concentration of elite talent seems far more critical in that specific domain than just the sheer number of people working on it.
Okay, final area then. Supplier dynamics. You mentioned winner takes most. The AV market for full-stack suppliers, the ones providing the whole autonomous system, seems likely to consolidate heavily. In that environment, what's the single most critical competitive advantage a supplier needs to articulate to develop just to survive?
One word, data. Or maybe two, data access. For companies aiming for full-stack solutions, the absolute mission-critical requirement is securing a close lead customer very early on.
Why early?
For co-development, yes, but crucially for fleet access. Access to real-world driving data from a fleet of vehicles. Data is the absolute oil of the AV industry. Without substantial amounts of real-world fleet data and, frankly, the significant funding needed to process and learn from it, smaller suppliers will inevitably struggle. They'll likely be relegated to just providing components, leading to that massive consolidation around a few key players who locked in data access.
Data is king. Okay. So let's try and synthesize this. What does this all mean for you, the practitioner scholar listening in? We've seen that autonomy is undeniably driving immense productivity gains, huge market value creation, especially in high-volume logistics like Amazon, and in commercial applications like trucking.
Yeah, the synthesis seems pretty clear. The full realization of all this potential, though, it's currently bumping up against two major external hurdles. First, unpredictable human behavior, both drivers on the road causing chaos for AVs, and unpredictable regulators creating uncertainty.
Right.
And second, that necessary and maybe difficult shift in corporate mindset, moving away from traditional hardware-focused R&D and sales towards these software-driven, customer-centered E2E business models that monetize features over the entire life cycle.
That's a big strategic pivot. So here's maybe a final provocative thought for you to consider as we wrap up. The most efficient machines. We're developing Amazon's robots, Waymo's trucks, their performance, their rollout. It's being constrained not really by technological limits anymore. It's being constrained almost entirely by the social, the ethical, and the regulatory frameworks that we humans create.
It's a human problem now, not just a tech problem.
Exactly. So for the practitioner scholar trying to model the next 10 years of automation, maybe the most important variable isn't the technology S-curve itself. Maybe it's the rate of change in human perception and regulation. What happens when or if the regulatory framework finally catches up to where the technology already is or soon will be?
That's the multi-trillion-dollar question, isn't it?
It really is. That unpredictable variable holds the key.
Thanks for tuning in to the Lion's Share podcast. If you enjoyed today's discussion, share it with a friend and join us next time for more ideas worth talking about. We'll see you next time.